In this warm-up, I'm introducing a lesson comparing different characteristics of direct variation compared to inverse variation. And we're going to be looking at different representations with ordered pairs, tables, graphs, equations, and trying to look at all the different representations so that any form it's in we'll be able to recognize which type of variation it is. And sometimes it's going to be neither type of variation. I introduced this variation. This is direct variation that I'm representing, but I'm introducing it to the students off of their prior knowledge of y equals mx plus b. So I asked them to write the equation of this line. So if you wrote the equation of the line, you need slope and the y-intercept. Well, the slope is just going to be a ratio of 1 up and 1 over, so that's going to be 1. And the y-intercept is going to be crossing the y-axis at 0. So if you wrote the equation y equals mx plus b, it would be 1x, or just x, plus 0. And so I tell them this is one type of variation that we're going to be looking at today, which is called direct variation. And I already passed out the Frere models to them so they could start filling in the type of graph that direct variation is and the equation. And so direct variation is going to have the equation y equals kx, where basically that's the same thing as y equals mx plus 0. That the y-intercept is always going to be 0. It's always going to go through the origin if it's direct variation, so the graphs you always can look that they're going through the origin. And the k is going to be equivalent to the slope. The k is the constant of variation that we'll find in different representations, but when you find the constant of variation with direct variation, it's going to represent the slope of the line also. So that constant of variation we're going to call k. But for example, if I had in this example that I already did, the slope was 1 and k is also, the constant variation is also 1. But if I had y equals 4x, well, that line would be going through the origin and have a slope of 4 over 1. So the constant of variation, if I asked for the constant of variation, it would be 4. And the slope would also be 4 because they're equivalent. If you had the equation y equals 1/2 x, well, what's the constant of variation? K equals 1/2. And the slope would also be 1/2. And keep in mind that sometimes, how else could you write 1/2 x? And remember, x, if it's next to the fraction, that means it's in the numerator. And so you could also write that as y equals x over 2. So keep in mind that that's still showing that the y-intercept is at 0 when that x is in the numerator, and that's still 1/2 x. So it's still y equals mx plus 0 or y equals kx, still direct variation.